Jnanam paramam dhyeyam. Knowledge is supreme.
Now we are coming to the end phase of our tutorial sessions. You might be enjoying the lectures, and by now you might have mastered how to use, or we are given lot of practice problems on commutator bracket, eigenvalue equation, finding out the eigenvalue, eigenvectors, and you have gone through a lot of exercises on ladder operator and things like that. So, I will be a bit sketchy in this tutorial, wherein I will just give you the hints or just the track or the road map kind of a thing to do the problems, and then you can just work out them. So, I will be giving only hints in this tutorial, and we would expect that you would try the problems and do them by yourself, and hope you enjoy this tutorial also. So, let us start with the first problem of the tutorial, which is about the interaction picture of the L and Z, that is the angular momentum and spin interaction. So, you have to supposed to find out the energy of the Hamiltonian, and here the problem given to you is that a Hamiltonian of the form upon h cross square, where Ls is the Ls coupling term. Okay. And in this problem you are asked to find out the energy eigenvalues or the energy values for the coupled system. So, let us start by writing. So, in this problem you are asked to find out the energy of the LS system, that is the coupled system for P wave. So, what do you mean by P wave? When you talk about P wave, L is equal to 1. Okay. So, we have L is equal to 1, S is half. We know that spin can take value plus half or up half, plus half or minus half, okay, for this coupled system. And so, the orbital state for P wave is 1, L is equal to 1, and when you talk about this coupled system, L plus S is J. So, now with L is equal to 1, S is equal to half, J can take values 3 by 2 and half. Okay. Now, we need to write L dot S in terms of L, S and J. So, how we can do that? So, if I write L dot S, 2 times L dot S is L plus S the whole square minus L square minus S square. I can write like this, correct. So, this would imply that L dot S is half, this is nothing but J square minus L square minus S square. Okay. Therefore, one can find out the eigenvalues for L dot S. So, eigenvalues corresponding to L dot S, you can write them into the eigenvalues corresponding to L dot S will be J into J plus 1 minus L into L plus 1 minus S into S plus 1 h cross square with a factor of half, which is coming from here. So, by putting the value of J, L and S, you can calculate the eigenvalues for j is equal to 3 by 2 and j is equal to half. Okay. So, let us write down explicitly. So, for j is equal to 3 by 2, okay, we are using L is equal to 1, S is equal to half, okay, we are using this. So, for j is equal to 3 by 2, the eigenvalue corresponding to j is equal to 3 by 2, you just evaluate this part, okay, by putting the value of j, L and S and obtain the eigenvalue. And as I told you before the tutorial that I will not be giving the results, I will be giving a roadmap how to go about and solve the problems. So, you can calculate the eigenvalue for L is equal to half. Okay. So, the energy corresponding to V R L dot S upon H cross will be, we have to calculate that, okay, for different values of J. Remember, before we go to that, the spectral notation you all might be aware that is written as J to S plus 1. So, L correspond to the state which whether it is a P wave, S wave, D wave, etc. So, for us L is equal to 1, so it is a P wave, so you will have a P. Okay. Then for two different values of J, you will find out what is the J here, and 2S plus 1 in our case is 2, correct. So, now the energy E is VR upon 2 for J is 3 by 2. So, you can this you have to fill this blanks and just match it with what I am giving you is the final result. So, E is VR by 2. So, for J is equal to 3 by 2, in spectral notation how will I write? I will write this as 3 by 2, okay. This you might all be knowing, and this will be V of R for J equal to half. So, the corresponding spectral notation would be this, alright. So, this is what you are supposed to evaluate. You can also calculate the wave function and things like that by your own. So, now let us go to the second problem. In the second problem, a Hamiltonian is given to you and you have to evaluate some commutation relations and some more results. Okay. So, this problem is divided into 3 steps. So, second problem, H is A Lx Ly plus Ly Lx plus B Lz. First part of this problem, you are asked to evaluate Lz. This is a very simple task. So, we know what is a commutator of Li Lj, we have done in the last class. Li Lj is I h cross epsilon I j k Lk. Okay. So, use that, you recollect what is Li Lj, okay. You have to use this commutator of Li Lj. And you will substitute for H over here. So, let me write one more step and then leave it for you all to evaluate. Ly Lx, this will be the first term, and the second term would be B okay. So, this will be the second term. you can evaluate these terms, right. For second term will give me 0, first term will give some result. So, this result is not equal to 0, you will check this and obtain the non-zero value. Okay. You have to obtain the non-zero value also. So, this was the A part. Now, we have to evaluate the B part. Okay. So, in the B part you are asked that you have to check whether Hamiltonian is the eigenstate of ket 1 0, whether it is an eigenstate of ket 1 0. So, for that I will take you now to the, just try to recall that. Okay, let me tell you that it is very convenient to use ladder operator while doing such calculation. So, you have learnt ladder operator for angular momentum, you can write it as L plus and L minus in terms of Lx and Ly. And when you operate these ladder operators on the ket, it will take the state from one step above or one step below. So, L plus will take you to the next step where your M will become M plus 1 and L minus will take you in the step downwards. So, when you use these ladder operator, you are able to simplify and work with. So, L plus L minus by definition is Lx plus I Ly plus minus. Okay. So, L plus is Lx plus I Ly, L minus is Lx minus I Ly. So, from this what do you infer? Lx is half L plus L minus, Ly is half and there is a factor of I, L plus minus L minus. So, these would be very useful in obtaining whether the Hamiltonian is an eigenket of 1 0. It will be very simple to operate L plus and L minus on the eigenket rather than Lx and Ly. So, what we do here is we first calculate. So, the steps would be, step 1 would be calculate Lx Ly. Okay. In the Hamiltonian, what are the terms you have? Lx Ly, Ly Lx. So, next is, then second is calculate Ly Lx. You have to obtain these two and then you rewrite the Hamiltonian in terms of the ladder operator. So, what you get after doing all this is just check whether you are convinced with this result. Okay. So, you must check this result. Check. Okay. And now you operate the Hamiltonian operator on the ket 1 0. So, that would give you, when I operate ket 1 0, I have 2I and then L plus will take the ket from 0 to 1, 1 to 2. Okay. So, you are going to, you cannot write it in the linear combination. So, basically you must be able to write the Hamiltonian as a or the operation. After doing this operation, you should be able to write this in terms of ket 1 1, 1 minus 1 or 1 0. So, L plus and L minus will is, there is a square. So, they will raise it twice 2 steps, L minus will lower it 2 steps. Okay. So, basically what you get here is something like this, correct, plus you have a B term which will give you 0, 0, 0, 1, 0. Okay. So, this is 0, this is equal to 0 times 1, 0. So, this implies that energy of the state is 0 and the eigenvalue is 0 for this. So, H1 operated on 1, 0, that is, this is a eigenvector or eigenket of the Hamiltonian operator with eigenvalue 0. Alright. Now, in the next part, that is the C part of the problem, you have to calculate the energy eigenvalue and the eigenvector. So, calculating the eigenvalue and eigenvector, you need to know again some of the basic things. So, the hint here is you will use the following. First, L minus, or I can write it as L plus L minus in one, I can club it. Okay. So, when you operate the ladder operator, plus or minus operator on the state L comma M, what I obtain is H cross square root. So, I will have a C plus C minus, which is nothing but the CG coefficient, Clash Gordon coefficient. I will have L into L plus 1 minus M into M plus minus 1 L comma M plus minus 1. Okay. So, L plus will raise the state M by plus 1 and L minus will lower it by minus 1. Okay. This is a compact form I have used to calculate to represent the ladder operator operating on the eigenvector or the vector L comma M. So, this is one thing you are going to use, and next thing would be Lz ML, which is M H cross L comma M, L square L comma M is L into L plus 1 H cross square L comma M. So, these hints you have to use to calculate the C part of this problem. Okay. So, in this, let us go a step further and use all this hint. So, I will just give you in a sketchy way how will you represent, how will you write the Hamiltonian operator in matrix representation, that you can calculate. So, what you will do is evaluate this, okay, and then what we can do is you can write the Hamiltonian in terms of matrix. So, just check if you can obtain this, or do you obtain something else, just check this. So, you have to calculate the eigenvalues and eigenfunction. So, the eigenvalue is, I can write it as E plus for, so eigenvalue basically is H cross square B plus A. So, this is one eigenvalue and the other eigenvalue is H cross square B minus A. I call this as E plus, I call this one as E minus, okay, and the corresponding eigen vectors or eigenkets would be, I call one of them as psi plus, the other as psi minus. So, this you can check by yourself that one can obtain this result. Okay, yeah, at this point I need not say, but for those who are not regularly solving the problems, for them specially, I would say that here the hint would be to calculate the eigenvalues and eigenvector. The hint would be to use eigenvalue equation, H psi is equal to E psi. It is not difficult. You have been solving this from day 1, from the first tutorial. So, it will not be that difficult. So, try and evaluate this. Problem 3 is you are given a set of Hamilton, the commutator relations, and using those commutator relations you have to dig down and search the results. So, one of this relation given to you is LZ V plus is given to you and L square V plus is given to you. Okay. So, these two relations are given to you and you have to evaluate or rather calculate what happens when Lz V plus Y LL. Okay. Here it is L plus V plus is 0, Lz V plus is H cross V plus. Okay. And this you have to tell me what do you expect. Okay. So, the relations given to you are L plus V plus. Okay. So, V plus is a kind of raising operator similar to your L plus, but it may not be exactly like L plus acts. It is a new operator. So, when Lz is operated on this state, what do you expect or what do you obtain is the question. Now, since you know this, so the hint here would be rewrite this as Lz V plus, okay, Y LL plus, we know the relation of Lz Y LL, we know this, okay, and okay, these things we know. When Lz is operated on YLL, it will give me ML H cross square YLL. This would give me L into L plus 1 H cross square term. Okay. So, these relations we know. So, going ahead, this is given to you, you can evaluate from here, and after doing 1 or 2 steps, you will get to the result of what you have to prove. So, after one more step, you can get to this result. In the second part, using the same analogy, using the fact that V plus when operated on LL would give some alpha L Y L into L plus 1. Okay. If this ladder operator takes you from L to L plus 1 and in some where alpha L prime, I have here this is a L prime. Okay. So, we assume that it is not a trivial operator and it may change L to L plus 1 and there is some L prime going from L plus 1 to some infinity. So, using this hint you can evaluate the second part or of the relation that you have to obtain. So, with this sketchy demonstration of the solution, I hope this would benefit you to solve the problems and get to the results. And in the second part also, we will try to I will try to write the steps involved in solving these problems. So, if you have not been doing rigorously the problems, then please try and do it again and again. I am repeating this all the time, but it is very important to understand both the theoretical part as well as the numerical part which you have been doing in the tutorial. And there is a whole bunch of problems available to you in various textbooks, and we try to bring a set of 5 problems which will give you flavor of different types of exercises you can think of and do. So try and attempt these problems, and we will continue next time.